In this demo, we will show how DCHQ provides end-to-end automation for Docker-based application deployments on DigitalOcean. DCHQ not only provides the application deployment automation, but it also automates the provisioning of droplets on DigitalOcean to create Weave-enabled scalable clusters. We will first register our cloud endpoint by navigating to the cloud provider section. And when we click on the plus sign, you'll see all the different cloud providers that we support. And we're going to go ahead and select DigitalOcean. We're going to provide a name for this cloud provider. So in this case, we're going to call it DigitalOcean DCHQ example. And then we're going to provide the email used to log into DigitalOcean. And then we're going to provide the access token. This can be retrieved from the API section in DigitalOcean. So you click on API and you would have to generate a new token. And we're going to call it DigitalOcean DCHQ. And we're going to go ahead and generate this token. And we're going to go ahead and copy this token. And paste it over here. You can also provide a group name, which is the prefix that will be given for the VMs provisioned. And optionally, you can provide the default size and region that you would like to use for this DigitalOcean cloud provider. You can also see the access controls for this cloud provider, so you can share it with other users and groups. So we're going to go ahead and click Save. And then the next step is to create a cluster. So a cluster is just a grouping of virtual machines or Linux hosts in general. And it could be a cluster of hybrid clouds, for example. But in this case, we're just going to create a DigitalOcean DCHQ example. And we're going to select the default placement policy, which is a capacity-based placement. And then we're going to make sure that this cluster is Weave enabled. So Weave will facilitate the cross-container communication across multiple hosts in order to ensure high availability. And then optionally, you can configure auto-scaling. And in this case, you can basically provide an auto-scale policy to set the maximum number of VMs that you would like to provision as part of this cluster. So this means that if initially we provisioned a couple of droplets in this cluster, that as developers request more and more Docker-based apps on this cluster, it will automatically spin up new droplets until it reaches that 10 droplet limit. So we're going to go ahead and save this cluster. And then the last step is to go ahead and just create a bunch of droplets on both the cluster and the cloud provider that we just created. So we're going to click on the plus sign, select DigitalOcean here. We're going to select the DigitalOcean DCHQ example. We're going to select our region. So we'll go ahead and select San Francisco. We're going to select the size of the droplets. So we're going to select 4 gigs, which should be sufficient. And then the image, and we're going to go and look for Ubuntu. But our agent is also certified with CentOS and Red Hat Enterprise Linux. Then over here, we can go ahead and open up some ports. So we're going to open up the port 80 and 8080, the 32,000 to 59,000 port range for Docker, the 5672 port for RabbitMQ, and the 6783 port for Weave. We're going to go ahead and select the data center that we created. And we're going to go ahead and provision 3 droplets on this cluster. And once we click Create and Configure, we'll basically wait until these VMs are provisioned. At this point, our 3 droplets on DigitalOcean are now up and running. We can perform historical monitoring by clicking on the monitoring icon. And we can view information like the CPU memory utilization, disk utilization, images pulled, and running containers. In this case, there are 3 running containers because we're running Weave in order to facilitate the cross host communication across containers. And you can customize the date range and view this information historically as well. Now let's go to the self-service library and request a multi-tier application. So I'm going to go ahead and click Customize on this application, and you'll notice that this looks a lot like Docker Compose, except that we've added some key enhancements. So this is a 3-tier application with a load balancer, an application server, and MySQL as the database. You'll notice that the load balancer here is invoking a bash script plugin that will customize the default.conf file in order to add the IPs of the application servers. The application server in this case, which is Tomcat, is clustered, so it has a cluster size of 2, and we're also invoking a bash script plugin to basically grab the latest Java war file and deploy it on top of Tomcat, and MySQL is our database. Now the key thing to note here is that we use the host parameter to distribute these containers across different hosts, and this we do this in order to achieve high availability. So in this example, we're deploying the load balancer on host 1. The clustered application servers are distributed on host 1 and host 2, and MySQL will be on a third host as indicated by host 3. Now this value doesn't have to be host 1, host 2, host 3. You can use the actual IP of the host you're deploying to or the host name, or better yet, you can use a wildcard. So if you know that the host name of the database starts with db-something, you can use that alternatively. Now if we scroll down, we can select the environment tag, and we're going to select the data center, which is in this case the DigitalOcean cluster, and we're going to go ahead and run this application. So our application is now up and running, and as you can see, the load balancer is running on a different host than one of the app servers, and MySQL is running on yet a third host. And the only exposed port here is that of the load balancer, so we can copy and paste this IP in order to validate that the application is up and running, and sure enough, it is up and running. And if we scroll up, we can see the action tab here that basically exposes all the day 2 actions or day 2 operations that we can manage for this application. So you can start and stop this application. You can edit this application and share it with other users or groups so that they can perform day 2 actions with you. You can monitor this application or all the running containers in this application and view information like the CPU, memory, and I/O, and this information can be viewed historically. You can schedule the backups of the running containers, so it will commit the changes to these containers and push new images into the Docker repositories of your choice or the ones that you've registered as part of this platform. You can execute bash script plugins and schedule those as well. And continuous delivery is our hook with Jenkins, so you can continuously refresh running containers with the latest build from Jenkins, and this is triggered as the new build becomes available. And then lastly, you can do the scale in and scale out. So let's go ahead and do a scale out example, and we're going to select the application server and increase the cluster size to 3. And of course, you can use this cron expression to schedule the scale out, so you can perform scale outs during peak hours and perform scale in during the weekends, for example. So in this example, we're gonna basically scale out the application server and do it on demand as we run it now. So the third application server has now been added and is up and running. Now what we can do right now is basically reconfigure the Nginx so that it now is aware of the new application server that we just added. So we're going to go ahead and execute a bash script plugin on Nginx. So I'm going to select the load balancer container here and search for my Nginx plugin that we had created. And I'm going to go ahead and click this plus sign in order to execute this plugin. And I'm going to opt to restart Nginx after this bash script plugin has been executed. And over here, we're just gonna say reconfigure nginx, and I'm gonna go ahead and run this. And if we scroll all the way to the timeline, we can track the progress of this plugin execution. And so at this point, it's being queued, and now it's been processed successfully. So if we go back to the application and refresh this, we'll find that the application is still up and running and has accommodated the addition of the new application server.